All right, everyone, let's go ahead and get seated. We're going to get our next enterprise case study panel up and going. So I wanted to start off. I'm actually going to have John, who's the CTO of Internet Associates, be the moderator and do the introductions for everyone who's up here. So John, I'm going to turn it over to you.
Thank you, Ed. Thanks for everybody both being here locally, both interactively on the internet, and then when you actually are taking a look at the video later on. Today we have a panel of our government experts. The first one is Mr. Ron Broersma, who's with the Defense Research Engineering Network. He is their chief engineer. We also have Kevin Jones with NASA, and Dale Geesey, who is has worked with the VA under contract. So I'd like to go ahead and turn it over to Ron.
Thanks, John. So I'm going to start by giving a bit of an overview as an intro to this panel, talking about a lot of the activities in the U.S. government over the last dozen years or more. I have the advantage of having a number of roles and being involved in a number of different networks and enterprises, and have been able to see this IPv6 deployment initiative from a lot of different perspectives. In one organization, SPAWAR, it's an enterprise network. We've been doing a lot of work with enterprise IPv6 deployment, and so we have those perspectives. I also am the chief engineer for the Defense Research Engineering Network, which is an ISP for the Department of Defense, and so there we look at issues specific to that environment. But then over the last number of years being involved in the Federal IPv6 Task Force, I've been able to see a lot of the issues that other federal agencies are facing as they deploy IPv6. And so it gives me a fairly broad perspective on some of the challenges and successes and lessons learned. So today I'm going to start by reviewing some of those activities over the last many years. If we look at the period about 1999 to 2006, some of the government efforts were really pioneering efforts, trying things out, building things, test bedding, setting up strategic plans, and just doing a lot of testing of equipment, and things like participating in the 6-bone and the multicast 6-bone, doing the Moon V6 deployment, which served as a good test bed for many years, and then various test beds in pilot like at DREN and SPAWAR and others. DREN did its test bed back in 2001, bought all dedicated hardware, spread it all over the country, dedicated circuits, but it was purely IPv6, and did a lot of work over that a number of years. And same with SPAWAR, and got some early enterprise experience there. But in 2005, the OMB set a goal to try to have all government networks be IPv6 enabled by 2008. And that had some success. It was a lot of work that was sort of waited till the last minute, but there was a lot of network backbones that became IPv6 enabled. Unfortunately, it wasn't. They didn't leave it turned on in many cases, and so it was only partially successful. But also in 2008, NIST published the U.S. government IPv6 profile, which had a lot of reference standards and the type of things you would want included in your products as you bought them from industry. And there were labs established to test conformance, ones like the University of New Hampshire Interoperability Lab that many of you are familiar with, I'm sure. But also there was the federal acquisition regulations that were modified to include this testing and this conformance for any products that one would buy in the federal government. And that is very important. In 2010, NIST published the guidelines for the secure deployment of IPv6, a very good reference document that you should all have as a reference. And then in 2010, there was a new federal IPv6 mandate signed out by the US CIO at the time, Vivek Kundra, which was a very clear, simple goal to try to make all of U.S. government IPv6 enabled, at least the public-facing services, by 2012, and then within 2 years after that, all internal networks IPv6 enabled. And so it was a very simple, clear goal, and a lot of work to try to meet those goals over the last couple of years. And so we've just crossed that milestone, the first milestone of September 2012. And so that's why this panel is important today, to talk about some of those activities leading up to that and looking forward. There also associated with that mandate was a tracking site for IPv6 compliant that NIST runs, and so you can look at that anytime, real time, just to see how the government is doing, and I've got some snapshots of that, which I'll show you in a second. And then also in 2012, most recently, there was a new version of the Planning Guide Roadmap towards IPv6 adoption within the U.S. government that was published, and you can get that off the www.cio.gov website, and many of the people here on this panel are major contributors to that document. And so those are just some good references, some history on where we've been, a lot of work behind the scenes that maybe a lot of people aren't fully aware of, but certainly the U.S. government has embraced this heavily and has been working very hard towards deploying IPv6 in the government. So the most recent mandate was the one signed out in September 28 of 2010, and the goal was to, by September 2012, have all public content IPv6 enabled, and by September 2014, all internal systems be dual stack, at least ones that needed to reach the internet. And I mentioned the previous OMB mandate, which was partially successful. The problem is a lot of people didn't leave it turned on. And then the Federal IPv6 Task Force, which some of us are members of, it's the team that's really working to make this all happen, or at least work with the transition managers and the agencies to try to make this a success. And so we've just crossed the milestone. Was it a success? And if you look at the status monitor, the NIST site that I reference here, on the left you can see the major cabinet level agencies and other major agencies in the government, and you look at that and you say, well, a success might be if everything was all green, and what we see here is some green, a lot of yellow, and a lot of red, which would sort of indicate that, well, maybe we didn't totally succeed and reach 100% of the goal. And all agencies are some level of compliance, as you can see, and almost none are at 100%. And then the chart in the upper right shows the tracking over the last couple of years, and you can see it was really flat for a long time, and it didn't pick up until the last 6 months, 6 or 8 months or so, where things, as we approached the deadline, really started accelerating. And then after the deadline, things kind of flattened out a little bit. And so what is that really telling us? What is the waiting until the very end? Is that people procrastinating? The spike at the end, does that mean everybody waited till the last minute to turn it on? Flattening it out, does that mean that since we're past the mandate that there's no longer an incentive to finish this job? So those are some questions that we'll talk about in just a sec. And then the pie chart at the bottom shows that at the moment we're at about 39% compliance, at least with the domains that the deployment monitor is tracking. So got a ways to go. So what does it mean? Why did much of the change come right before the deadline? And then if the metrics only show 39% completion, does this indicate a failure to meet the goal? And then after September 2012, what's the incentive to leave things turned on and to continue making progress? So on the first point, I think it's not so much that people procrastinated, because I know a lot of the behind-the-scenes activities that went on over the couple of years, and there was a lot of initial planning, training, learning, contracting, a lot of efforts behind the scenes to try to get these enterprise networks to be IPv6 ready. And you cannot imagine the amount of work that goes on in some of these federal bureaucracies and these large enterprise networks and working with their ISPs, constrained by things like trusted internet connections, which they need to go through in order to reach the internet, and the certain service providers which might not be quite ready, or infrastructure that might not be fully IPv6 enabled, limited budgets so you couldn't replace all your hardware, and so a lot of issues that they have to deal with. So there was a lot of behind the scene work, and so naturally a lot of things didn't get turned on until the very end when the final pressure was on. So I don't think it's any indication people were procrastinating, although that was the case in some cases. It was just because of indication of how much work was involved. So red doesn't really mean no progress. To get to green, you had to plan, procure, do all your contracting, do your training, get all your people trained, do the testing, installation, configuration, for all of this IPv6 deployment. There's a lot of work that goes to getting to where your public services are IPv6 enabled, and so which is what's measured. And so when you get to green, that means it's fully operational, but there's a lot of work to get there. So that's really an indication of a lot of work that went on behind the scenes. But by the September 2012 deadline, there were approximately 800 domains that made some progress. There were 1,200 unique public .gov services that are IPv6 enabled now, and approximately 30% of the public web.gov sites that are being monitored are IPv6 enabled today. So I think that's really huge, because if you look in any other segment of the world, comparing government to industry to education to research networks and so forth, this is huge. There's very few other places that reach those kind of numbers, except in maybe small sites or some of the smaller countries. So was it a success? Yes, I think it was a huge success. Because for one thing, think about the significant increase in the demand signal from the U.S. government to industry to deliver IPv6 services. Instead of a few of us IPv6 advocates begging our providers, please turn on IPv6, and being ignored, when you have the weight of the entire U.S. government saying we have a mandate to meet, please deliver these services, and I need it by these deadlines, that's a huge increase in demand signal. So that's really important. So it's really a lot harder for industry to just give it low priority. They have to give it some attention. And it kind of explodes this myth that nobody's asking for IPv6, which is what we heard from a lot of vendors for a while. But also internally within the government agencies, there's a huge increase in IPv6 awareness. Because these organizations have had to do their training, they've had to do planning sessions, they had to come up with strategic plans for how this was deployed and get a lot of people involved through all the sub-organizations and the sub-sub-organizations, and so that awareness has really increased. And so that has really helped as well. Also, there are a lot of commercial products that have gone through the conformance and interoperability testing. And so you can go to the NIST website and look at products that have gone through the labs, been tested, help you in your selection process. Also, a lot of public government content is becoming IPv6 enabled, and this is part of the world goal to make the entire public internet IPv6 enabled, which is really important, and that's the highest priority at this juncture. And so the government's really part of the solution and no longer part of the problem, and really setting an example as being a leader for other segments of the internet. And hopefully this will set an example and others will follow in this. And we know this is the case because a number of other governments have talked to us in various forums saying, we'd like to do something similar. What are your lessons learned? Should we do it faster, slower? So we've been helping in that area, so that's very exciting. So some lessons learned on this exercise. Number one, you want to gain some operational experience before putting too much effort into enterprise-wide planning. I've observed this in many agencies and organizations, is taking the typical planning approach where lots of people involved in doing lots of reading and studies and producing big plans, as if the entire plan had to be done before you do anything. And that is really not the case, and especially related to the address planning piece of it. Until you gain operational experience with IPv6, spending a lot of time planning might be wasted, because what I've seen in those plans are they make assumptions based on the IPv4 world and products as they exist there, and there are so many unknowns. Plus, if you lack the experience, you will get the plan wrong, especially your addressing plan. It usually takes about 3 times at a minimum to get it right. And sometimes a lot more. So you really need to make sure that you have an incremental approach to deploying IPv6. Don't be afraid to break some glass, turn some things on early, use spiral development, and really develop the overall plan over time, incrementally, as you deploy smaller pieces, then larger pieces, and then even larger pieces. That's really important. Next, go native. And the word native is a little bit confusing because it was a word that was used in the mandate from the USCIO, and some people thought that meant IPv6 only and that they had to turn off IPv4. And this really tripped up a lot of folks in the beginning because they were trying to figure out how to work in an IPv6 only environment. But that's not what that meant. Native meant that you are avoiding things like tunneling and translation and are doing instead IPv6 end-to-end, which is the ultimate goal. You can still do IPv4 and run in a dual stack environment. So the transition approach of choice is to run dual stack, and wherever you can have native end-to-end IPv6 connectivity. Only use translation and tunnels as a last resort, only at the very edges, as far out to the edge as possible, so that you're impacting only yourselves and not anyone else. Also, it's best to start from the outside and work with your ISP, make sure they're dual stack, and then get BGP working, and then get your DMZs v6 enabled, and then work through your firewall and security stack, and gradually work inward. It seems to be the best approach. And then along the way, you get your public-facing services IPv6 enabled without a lot of the challenges of getting it to work through your full security stack. There's going to be surprises along the way. Another reason why you can't do all the planning up front, because some things you will not discover until you start turning it on and using it in your environment, in your architecture, and you may have to re-engineer some of your networks because of features that are missing, or maybe your particular vendor doesn't provide all the products or capabilities or the feature parity between IPv6 and v4. So be ready for surprises. They will be there. Also, it doesn't require significant resources if you start early and leverage tech refresh. At least in all the initiatives I've done, other than the original testbed in 2001, there was no additional funding. It was all done as we did technology refresh in the hardware. We made sure that we purchased IPv6 capability in all of those products. And so no extra staff, no extra funding. We just did it carefully over the course of 5 to 7 years. So the other message is that if you have not started yet, you don't have 5 to 7 years. So if you haven't started, you waited too long, you will probably have to make some investments in order to accelerate the deployment. Now, looking forward, what's the incentive to keep the pressure on for government agencies after the 2012 deadline? Well, the incentive is going to be there's a policy emerging that .gov domains will not allow to be renewed if that organization has not met the mandates for IPv6, and this may be extended to DNSSEC as well. So this looks like it's going to be a really good stick to enforce making sure all the agencies are compliant, and we've been talking to other domains as well to see if a similar incentive would work in other communities, and there's certainly some TLD providers and other governments and countries and organizations that say this is a really good idea. This is maybe the incentive we've been looking for, and so encourage others to consider that as well. Also, there's other U.S. government CIO initiatives out there that do leverage IPv6, like digital government, the data center consolidation, cloud initiatives, and so forth. They all have IPv6 as part of the core, so hopefully that'll add additional demand as well. So finally, some keys to success. Looking back at this, what did we learn that made it a success for others to use in the future? First, a clear, simple, achievable vision and mandate with deadlines from the top, like the CIO level. This was very important. Keep it simple, clear mandates, something that's achievable really can help. But also you need the responsibility, the accountability, and the authority to be established and managed at the executive level. So at a high level, you need to authorize everyone within your organization to do their part to deploy IPv6. If it's just the network team that's trying to push this, it will fail. If it's just your web administrator that's trying to push it for the public website, they will fail. It's got to be everybody who is authorized across the board to do their particular piece. Applications may need to be rewritten. Hardware may need to be replaced. Software may need to be upgraded. It just permeates the organization. So you need a whole IPv6 culture. Public reporting of status along the way, internally and externally, so you can see how you're doing. This is like the NIST website that shows government progress. That was really important because the agencies can see how they compare to other agencies. It keeps everybody honest on how well we're doing. There's nothing to hide, and it's just a really good incentive to track how everyone is doing. You may need to bring in experts from the outside. Especially a large number of organizations I've seen have outsourced their IT expertise, or they have no organic internal IPv6 expertise, and so you may need to bring some experts in for a while, and this can really accelerate your efforts, especially if you don't have any internal operational experience with IPv6. Rather than develop it yourself over a year or two, just bring in some experts from the outside and that'll get it going faster. And then you need early and consistent interaction with all your service and technology providers. Let them know what you need early on, keep pushing, work with them, and if they do not respond, be willing to switch vendors, go to another provider, be it an ISP, be it a hardware vendor or whatever. And even in my organization, we got folks trained that if a vendor wants to sell us something, say it's a new vendor that wants to have a meeting and present their products, first thing we do is we go to their website. If it's not V6 enabled, they don't get any farther. We just send them away and say, do not come back until you have that fixed. And I hope you all are doing that as well. Because if there's companies that aren't doing V6 even on their public website, then they don't have a good V6 story. And we don't want to talk to them these days. It's 2012. You should be there. And so keep pressing your providers for doing that. Also, of course, another key thing is dual stack support from your ISPs. There still are some ISPs serving federal agencies that cannot provide IPv6, unfortunately. And for those agencies behind them, they're stuck. And but even for home users, if your cable modem or DSL provider cannot do IPv6, you're stuck. You may have to do a tunnel or something like that. So it's really important that the ISPs provide dual stack. And you may have to switch if yours doesn't. So those are all keys to being successful. So I think that's enough for an intro, and I'll turn it over to some of the other guys for presenting individual agency experiences. So, and you can contact me at that address.
Thank you. I am here representing the IPv6 Forum. Latif, Ladid, and Yannick could not be here for the meeting. So what we have here is Ron is being presented with the IPv6 Forum Internet Pioneer Award for his last 12, 14 years of work in supporting IPv6 and really being one of the key advocates for it for a number of years. Congratulations.
Thank you. Thank you.
Kevin Jones with NASA.
While he's pulling up the presentation, I just wanted to say what an honor it is to be here, and privileged to be with such a distinguished panel. Congratulations, Ron, on your award. You're definitely deserving. He's done tremendous work with DRAN and SPAWAR, and he's definitely, as are Dale and John, one of the people I go to when I'm looking for support information on our implementation. Dale Geesey, for his support of the VA, and he actually supported our organization by coming and giving a great presentation on how to use the USGv6 profile. John Lee is part of ACT-IAC, has been supporting our FedV6 meetings, hosting WebEx for them, and making sure that the technical sub-team meeting has a wealth of technical presentations from various vendors. So these guys have been great and very supportive in the NASA implementation. So as Ron mentioned, there was a memo that came out in 2010 that outlined the direction for the federal agencies. There were pretty much 4 things that were contained in that. One was that each agency had to name an IPv6 transition manager. The other thing was the procurement piece, making sure that your IT purchases were IPv6 compliant. And then the 2 main goals, the first being implementing the public services, and then for 2014, going in the opposite direction, making sure that if you had an internal system that had access to the internet, that also had access to IPv6. So just wanted to give an update on where NASA stands in terms of their implementation. We spent a lot of time doing planning and probably should have started implementing sooner, but we are making great progress now. And our first start of turning things up started through our partnership with Akamai. Through their program, we were able to turn up about 70 of our public-facing websites, and this included our top-level domain, and all of that was completed in April 2012. This has enabled us to participate in World IPv6 launch in June of this year, and even though that was a great first step, that wasn't stuff that was actually on our internal network, and it actually represented less than about 5% of what we actually had to implement for the 2012 mandate. So NASA has about 1,600 public sites that they need to implement for the 2012. We've known for quite some time for various issues that we were not going to be able to meet the mandate and had reported that as such. And so our target right now is to make significant progress by the end of March 2013, of which we expect to have about 75% of those 1,600 sites implemented. And that plan is to do that with dual stack. So Ron started talking about the NIST IPv6 deployment monitor. I have fortunately a little bit different pictures to show. This is actually just specifically on what you would see if you clicked on a federal agency. This is the NASA status. And so in our case, we have 6 secondary domains. We have implemented 100% for our DNS and our DNSSEC, and we just got our first domain implemented just this past week, and so we are making progress. There's still a ways to go. One of the things that Ron also mentioned is the plan to have domains be required to be IPv6 compliant before they renew, and that actually is something I think is great. It's be useful for us. A lot of these things that are tracked on the NIST deployment monitor, they're just the secondary domain, so it doesn't show all of the sites. And at least in the case of NASA, I'm sure this isn't unique, a lot of these secondary domains are collaboration sites, so they're not necessarily sites that we have control over. They're supported by external organizations, whether that be companies, universities, what have you. So actually having an extra added push to get those sites to implement IPv6 is very welcome. Oops. So we currently host the FedV6 monthly working group meetings at NASA headquarters. Those are available through WebEx, through John Lee, and audio conference for those who are in the DC area like myself. We started out by actually forming groups, and I think the really impressive thing for me that's made this a lot easier is just the support that I've been getting out of the NASA OCI organization. When we developed our working group, they made sure that each of the centers had representation. We were able to get the group to be an official chartered group. We set up specific technical areas or sub-teams to discuss various topics, so the routing, web and application security are some of the ones that are really meeting on a regular basis. We just did the standard things of any project of setting up distribution lists. We have a SharePoint that has a bunch of the presentations and information. We have an internal website that's open to the agency. We meet on a regular basis. We have bi-weekly meetings. And again, just the support from OCIO, the members that are engaged in the working groups, and even the IT projects, when we come across them and raise the IPv6 issues, that's actually gone fairly well. I, as the NASA IPv6 transition manager, brief the CIOs of the NASA centers on a regular basis. That generally happens every 1 to 3 months. And one of the things that I include is a status of where their centers are. So it is generally a stoplight chart that has a simple red, yellow, green status on where they are with their implementation. Okay, some of the directions and policies that NASA has been looking at in their IPv6 planning. We're definitely looking at using dual stack, so we're expecting that to continue for quite some time. And We are really trying to disable tunneling by default, so this is something we're already in the process of trying to set up for firewalls. I've actually been reaching out to folks to get those rules this week. And we're also even looking at doing that on our desktops, as we have a agency desktop contract, and that should be something that could be rolled in. Our standard documents for our systems, I think for some time now, we've actually had those so that it specifically says do not disable IPv6. So that's already rolled in. And in terms of our IPv6 address space, we currently have a /32 that's assigned. And so I think you'll hear from Owen later today in terms of his presentation on address planning. One of the things is we probably need to look back and see if the /32 is really a good match. One of the things he will suggest is that you really should be figuring out how much address space you need as opposed to taking a /32 and figuring out how to make that work. And then the other piece is to address the concerns, the fears, really looking back at the IPv4 policies and making sure that if there are parity updates that need to be made for IPv6, making sure that that actually happens. So we have faced several challenges with our implementation. One of the more serious ones was our issues with our security vendors. NASA has a security operations center, and we had more than one vendor that had issues with their IPv6 implementation, and NASA made a decision that we were not going to go forward with implementing our sites until we could confidently monitor IPv6. And so as a result, that ended up delaying our status. In fact, even with using a workaround, this issue wasn't really addressed for us until a few days before the deadline was implemented. So one of the I would say the takeaways from that is that being proactive, you have a large inventory of IT equipment. I would suggest starting to audit that equipment, make a determination, is that equipment something, the stuff that you actually have now, is it legacy? Does it have no support for IPv6? Does the company have any plan to support IPv6? Is it some partial support and they're working on their roadmap for that, or is it some full implementation and you just need to verify what their real status is? And then expect to have issues. I think for the time being, there will be vendors that have implemented IPv6 or have implemented some portion of that, and so you're going to need to expect to have those and expect to work through those. Definitely using the USGv6 profile and the IPv6 ready programs to ensure your IPv6 compliance for your new purchases. Don't add to those problems. So the other issue was training. Everybody, this was new to all of our IT staff, and everybody needed to work on getting IPv6 training. That includes the networking people, the security folks. And so we ended up having to conduct some agency IPv6 training sessions, but also pairing that with just the various conferences such as these, different seminars. Fortunately, there's a lot of IPv6 evangelists out there giving various presentations, but definitely taking advantage of those. And so the takeaways with that is it is important, but you definitely need to develop the opportunities to get the training in-house, develop your IPv6 labs to do testing, and expect that training is going to be an ongoing activity. It's not a box that you're just going to check and say, okay, people are trained and we can go forward. That's an ongoing process. When you're looking at your vendors, if you are bringing trainers in, there's a host of trainers out there. Make sure that you check their status and go for best value over lowest bidder. You don't want to be trained by somebody who's reading the book the night before they're training you. Okay, so one of the things, and again, Ron mentioned this too, we were one of the guilty agencies. We just spent too much time working on our IPv6 address plan. And that was time that could have been spent elsewhere. In fact, I think last year when I was here at this conference, I was trying to figure out how we were going to get past that. So that's something that we still have to work through. We actually had to take a step back and focus on what is actually needed for the 2012, and the idea was that we were going to focus on at least finalizing the details for the public IPv6 address portions. We really need to follow the recommendations of people with operational experience, and that's the FedV6 task force, the people who have already done it, and just the concept of realizing that your address plan is not going to be correct the first time, accept that, and really start testing out those theories, those ideas. They may sound great, but test them in the lab, quickly figure out if they're going to work, and if not, readjust and move forward. Okay, and I think a couple of people have now mentioned this, that just in terms of the budget, this was not something that we got additional money to do. And so when we looked at our implementation, everybody that was impacted, everybody's impacted by IPv6 is far-reaching, that was something that had to be rolled in existing budgets. And so one of the ways to do that is if you're starting early, you get to leverage technology refreshes. If you're buying new equipment, make sure that that equipment is IPv6 compliant. So the piece of that is that the contracts piece, making sure that your contracts know that they need to be buying IPv6. Fortunately, with our IPv6 working group, we have enough people that are engaged, that are paying attention to the project reviews, and that are bringing up, hey, is this IPv6 compliant? What are your IPv6 requirements? But those are things that should be part of your standard review process. So if you have a formal project management process, making sure that you have IPv6 checks for those, and making sure that this information is out there to everyone. So you have to gotta publicize that this is something that you're doing and make sure everybody can follow it. Okay, so some of the things that are coming up for us in terms of continuing to make progress on the 2012, we're getting really close to where we can say that the infrastructure is turning up, at least for the public side, to turn up the websites. So centers are starting to peer with the WAN backbone that's up and running with IPv6. They're doing their configuration on the firewalls and setting up the enclaves that are necessary to support those websites. So then we turn things over to the web POCs and the system administrators that actually have to request their IPv6 addresses and get those entered. They have to make sure that the right ports are opened. And from my standpoint, I'm looking for a response that actually lets me know that they've gotten their website working. And so I've found this website, IPv6 status check. You can actually go out and it'll test the web, the mail, DNS, and give you a response back on whether things are working properly. And I'm actually requesting that I get screenshots because I have too many websites to track. The 1600, I'm looking to set up a SharePoint site that I can track by center, much the way the NIST deployment monitor does, on what the status is. So if anybody from a center or CIO or what have you comes and asks where we are, I can easily give them status on where we stand. And then going forward into the 2012, I mean, agencies need to continue to be engaged and making progress. And I've been checking the NIST deployment monitor. I've seen that as it's still been happening. Agencies are still making progress, but I think there are things that we're going to be needing to continue this forward. We still have to finish up the 2012, we still have to start planning for 2014. And so in terms of facilitating agencies to continue to make progress, I think now that we've actually really started to implement things, more agency presentations that are sharing the successful implementations, the challenges that have been resolved, or even the hurdles that they still need to be resolved. So just looking for more of the collaboration from a federal perspective. Ron mentioned this too, dealing with the vendors as a federal group. Now the vendors, when we were dealing with them and we raised issues, it was useful to have deadlines, but the next deadline is 2014, and so we really don't want people waiting, the vendors waiting until 2014 to start turning things up. We really need them to understand if we're going to meet a 2014 deadline, you actually have to get your stuff working before that. Getting it working on September 30th, 2014 doesn't enable us to meet the deadline. So getting that support from the FedV6 task force, GSA has helped out with the networks vendors, and some of those issues are still working. And then I know that there's been discussion of the USGv6 profile. I'm not sure if that's still being worked on, but right now it does only cover a few areas of IT purchasing. So if that's going to be expanded to start including, say, software, stuff like that, getting that in and making sure that we can, if we come up with a process that says SDocs are required, that can be applied to everything. I think that's it. So I'll leave it to Dylan.
Thank you, Kevin. Yeah.
Control L.
Control L.
Well, good morning. I hope everybody's enjoying the presentations and the talk so far. I do want to thank GoGo for inviting me to come and speak. I've been in the past ones. I think this is a great venue. I love the room. I love the area. I think it really is a great place to talk about IPv6. Now, I've got a number of slides here, and I could spend hours talking on the subject. And I've listened to myself talk. Believe me, you don't want me to spend hours talking. So I want to go through, run through these pretty quickly. If you have questions, I'm happy to take them now. We're going to have a panel time at the end. You can do questions then. If you have other questions that pop up, don't hesitate to just pull me aside and ask me. I'm happy to do that. One of the things I do want to talk about, Ron was talking about, what needs to go in to make a good IPv6 transition. One of the other things I think is very critical is having the team there, starting with your senior team and your senior buy-in. And this is something that the Department of Veterans Affairs has been very lucky with. The CIO, Roger Baker, has taken a special interest in IPv6, so he's done a lot from a policy perspective, from pushing it. He's been part of the CIO Council, the Federal CIO Council, really pushing IPv6 there. The Deputy CIO, Steph Warren, has taken a very strong interest in this and pushing forward. We'll show a couple things that they've done in particular. But then also the transition manager for VA, Steve Prochowski, he's been in there. He's been in there since probably about 2005, really pushing this. And it's not even a full-time job for him. This is kind of his part-time job on top of his full-time job. So he's done a lot to move the VA forward. And then people behind the scenes like Mr. Wes Crum, he's been working within the VA. But they've done this across the entire department. They've pulled in a group, a very large group, who they bring in. They've got probably 20, 30 people easily monthly who get together for the working groups. They invite outside people. So they've really done this as a cross-integrated team across the entire department. So I think they've done that right. So a couple things. I think we've talked about these already. OMB 2012 milestone, basically all your public-facing services need to be IPv6 operational. 2014, a little nuance to the requirement, but it's the internal services that reach public services on the outside need to be IPv6 operational. And as Ron mentioned, there was a update to the federal roadmap that was released. You can go on cio.gov and download it, and it provides more description and detail in there about what those milestones really mean, a little bit more guidance on those. And then World IPv6 launch, the government was part of it. If you want to look back and look at some of the pieces, NIST actually put up a specific site that showed how many of the agency's websites were up and running for the launch. You had about 2,600 websites up there. So you had a lot of, 2,600 overall. You had about 130 VA federal domains up there running. So interesting, a lot of the measurement pieces. If you haven't looked at those, definitely a good area to go back, take a look at, even though it's a little bit dated now. But going back out to the VA, what are some of the major transition drivers for VA? So, like many agencies, there's the federal directive. OMB comes out, the White House says, you'll do this. It goes on the screen, they look at it, and they start to move forward. And a lot of agencies will tell you, and this is absolutely the right way to do it, is they'll look at the federal directives, they'll look at their mission and see how closely they align. And the more closely they align, the more focus they'll put on them. So outside of the directive, technology leadership was an important area for VA. They deliver a lot of services to veterans, and they look at technology as a way to deliver that service better, faster, cheaper. So that becomes a critical component to them. Cost control. VA has a large IT budget. I think the last time I looked, their IT budget was about $3.1 billion a year. They're one of the largest federal agencies, definitely on the civilian side for IT budgets, and they need to find ways to continually control costs. And layering in new technologies is one of the ways that they try to do that. And then veterans service continuity. They want to make sure that they continue to service the veteran no matter what happens. And utilizing things like internet video, internet chat rooms, things like that, those are critical components. But by far, the biggest driver for VA around IPv6 is the idea that soon we're going to have these IPv6 only veterans out. You've got ISPs that are moving to IPv6 today. You've seen the address exhaustion on the IPv4 side. And it's critical, as you get down the road, these veterans are going to have internet services that are going to be IPv6 only. They may have the ability to go through some sort of large-scale NAT. Well, the VA's looked at some of these pieces, and they're trying to do in-home medical health care, telehealth services, and they're afraid, rightly so, that a lot of these services aren't going to work right going through multiple layers of NAT. They need to be able to deliver some level of quality of service to be able to make these veterans, be able to service these veterans. And so they're looking at it, and a large number of veterans, probably over 40%, live in rural areas. Most of them probably have some form of internet access today. It'll probably change greatly over the next couple of years as broadband continues to deploy. And as those networks continue to expand and new networks are deployed, those will be the IPv6 only networks. So again, a very, very critical driver. Now, so from the VA perspective, we put together an execution timeline. And it mapped very closely with what the OMB milestones were. And you can look and see from the 2012 perspective where they mapped in, and then the 2014, and then I'll talk about the 2015 milestone. That's a VA-specific milestone soon. But this kind of gives you a high-level overview of what VA was looking to accomplish when, was, and is going to accomplish. Now, one of the things that VA did that's a little bit different than other agencies, their CIO came back and said, all these other pieces are nice, but one of the things we need to take a look at is, what do we do beyond IPv4? Do we need to look at turning off IPv4? And the decision was made for a number of reasons to start building that into the plan. And you can hear a lot of debate and a lot of discussion in the industry on this, should you even consider that now? Well, VA is looking at it and saying, well, we've got a lot of internal networks that we run. We'd like to move off and not run dual stack for an extended period of time. We think there's going to be additional costs in running dual stack. We think there's going to be additional problems. We've got medical devices. We've got a number of things that go on that have to go through specialized certifications. We've got numbers of operational people. We've got, VA has over 500,000 employees and contractors who work with them. They service over 26 million veterans. They've got a number of things that they have to work with. And where they can, they want to start doing this. Now, this doesn't necessarily mean that 2015, all V4 is done, is gone. What this means is they're going to do it in a smart manner. They want to try and turn as much V4 off as possible. Obviously, if you've got veterans out there, if you've got external users out there that utilize V4 to reach in for services, they're going to continue to support that. But on the areas in the backbone, other areas where they can start turning off V4, that's where they plan to do it. And this is kind of the line in the sand that they're using to drive that. And the other thing we started looking at from the VA side is there's a lot of things within V6 you want to be able to do to improve, to leverage benefits around V6. And one of the challenges is as you have V4 continually deployed, you're trapped into a V4 architecture that makes it harder to do that. And so the other idea is we're going to build in better ingenuity. We're going to be able to leverage those benefits better, sooner, than if you did a longer extended timeline. So progress measure. So VA's put a lot of emphasis and effort around IPv6 over the last several years. One of the things that they've done is really focused on meeting the 2012 mandate, or milestone. And VA has about 523, a little bit under 525 domains overall. If you look at the NIST monitor, I think there's only like 8 or 9 that appear because those are the second level domains. But beyond that, under va.gov, VA operates a large number of domains. So from an overall perspective, we worked with a large number of those domains. And you can see for the most part, it's done. And in fact, from the VA's perspective, they pretty much met the 2012 mandate. The only outliers they have now are services that have been externally hosted from like cloud providers or other hosted providers, and they're going through the contractual actions. You know, they had to let certain contracts go through the course, renew, or select options. So they're in that process. I think they've got maybe, and I think these are actually some older numbers. It's even less than this right now. So maybe out of 523 domains, they've got maybe 1 or 2 left that they've still got to move in that form. So overall, they think they've done extremely well from the 2012 perspective. And some of the success highlights for VA. Well, VA actually turned on the primary domain, www.va.gov, for World IPv6 Day in June of 2011, and left it on. Now, you had a number of agencies who participated in World IPv6 Day, but very few left it on. And I think if you look, SPAWAR and DRAM were probably one of the few other ones that did that. And so, that was a very strong message from the CIO that said, hey, we're going to get it up before this day, we're going to leave it on, we're going to continue to make progress. The other services, the remainder of the domains that VA was running from a web perspective, the DNS services, all those were completed before the end of the calendar year in 2012, or 2011, sorry, well before the OMB milestone. And that was, again, another statement that VA wanted to come out and show that it's moving from a leadership position. The email, the SMTP services occurred very early in calendar year 2012. Again, moving forward. And then moving forward with the other pieces. VA's also been very focused on doing a lot of work from an interagency perspective. VA hosts 2 interagency meetings a year. They do a lot of coordination between the different agencies. Steve Brachowski from VA runs the outreach subgroup that's part of the Federal IPv6 Task Force. So they try to share those lessons learned. They try to pull in the different teams and help do an understanding across different agencies. Another one we'll talk a little bit more about is VA actually went back to ARIN and got a larger allocation, the /24. I've got another slide on that, and then we just talked about the cross-agency support. Something else VA has been working on has been the overall acquisition systems. If anybody's familiar working within the federal government, acquisitions is a very large, challenging beast. And it's very difficult even within a single agency to get all your acquisitions in a centralized manner and a centralized methodology. And then you've got hundreds or thousands of acquisition people running around who work, and they all have to be trained, they all have to get in line and understand what's going on. And it's not just on IPv6, it's about everything that occurs from a federal acquisition basis. So you've got hundreds of things that are moving parts, and you have to try and keep that online. So one of the things VA has focused on is trying to do that from the overall standpoint, because controlling those acquisitions from an IPv6 standpoint is critical. You don't want to go out and buy any more equipment that doesn't support IPv6, or at least, and definitely the features that you want. And it's not just as simple as saying, hey, can you do IPv6? It's, can you meet the USGv6 profile? Can you do these things that we need? Can you still maintain the performance? Can you do all these other pieces? And tying that into the overall solution set. And VA's, I think, done a pretty good job on that. And they've got a centralized methodology for the majority of their IT acquisitions. And so this is an example of the screenshot. Whenever one of the contracting officers or the program managers logs into their acquisition system, it brings up what they need to do from an IPv6 standpoint, reminds them, add that into your procurement, make sure that's part of it. So I won't say they're 100%, but they're getting better and better. Other significant activities we've been working with VA on, they're looking at doing a IPv6 VPN telework implementation. And this is critical because some of the services, not only for their teleworkers, but also for their veterans, come off these VPN services. So that was something early on they wanted to take a look at. And so they actually implement a number of end-user VPN solutions, and we've gone through and analyzed those and put in place the roadmap for getting there for that. Cloud pilots, if you haven't been aware, the federal government overall has had a large focus on cloud lately. And we're a firm believer that IPv6 and cloud go together. I don't think you could really do true, good, continuing cloud solutions without IPv6, in my opinion. And that's what we've been looking at from the VA standpoint. They've been doing a number of cloud pilots with their partners and moving forward, and we've been working V6 into that mix. The V6 profile process. So VA's taken what NIST put out. We've gone through, we've done a little bit of look, we've refreshed it, we've built the process internally for VA on how we go through and build out those profiles. So if you are familiar with the NIST USGv6 profile, it itself to me is not really a profile, it's a profile process where you build device compliant profiles. Well, we've created a methodology for VA to go in and do that so they can go out and say, okay, I'm going to buy this router to do this, let's generate this profile. I'm building these medical devices, let's go generate this. And the main focus is that USGv6 profile, but then tying on everything else that you have to. So if VA is buying medical devices, it's not just USGv6. There are other mandates and regulations they have to meet from a medical perspective. And so they may have to get compliance and testing from other U.S. organizations or other groups for those. WAN IPv6 implementation, this has been critical. We've been working with our carriers. VA uses a dual carrier network for most of its traffic, and we've been working closely with those. And you know, Ron had mentioned working with vendors, absolutely critical. For a lot of the early success, VA worked with some of the vendors, Brocade, F5, Cisco, some of the carriers, primarily CenturyLink. We've been working with AT&T to bring them along as well. So there's a lot of vendors who sometimes they step up, they're out in front, sometimes they need to be dragged along a little bit, but at the end of the day, most of them actually do step up and we're getting the services that's necessary, but you've got to ask for it and sometimes you've got to push for it. And a lot of the vendors don't understand at the senior level that these are really being asked and requested. I've sat in meetings with senior VPs from some of these carriers after I've gotten out of agency meetings talking about the needs for V6, and the senior VPs are talking about, well, we don't get any requests. Well, then your process for getting the feedback back from your sales team and your engineering teams are broken because we've been pounding on them for the last 6 months. And so that becomes a critical aspect to make sure that those people who make decisions, because those carriers, those vendors aren't going to build the time and the requirements for V6 into the products unless they see a direct impact and need from their customer base. And then Vista IPv6 proof of concept, and this is not Microsoft Vista. This is actually their healthcare system, that healthcare record system that was started back in the 70s. It still runs on a lot of, shall I say, older, more proven legacy systems. And that in itself is a challenge. So you've got these health record systems that have been around for decades that are running on equipment that's been continually, well, not the equipment, but the operating systems and the coding languages have been continually updated to meet their needs that they're not necessarily going to go away from. Now you've got to figure out how can that run over V6? What are the challenges? And we're doing a number of proof of concepts with them, setting up labs and demonstrations to help them do that. So IPv6 addressing. This is one of the areas that VA took a look at and was critical that says, hey, we went through, or VA went through initially back in the mid-2000s and said, yep, we're going to get our address base, went out, got the /32, said we're done, we're okay. Well, when they started actually going to looking about what they had to do, where they had to deploy, how they were going to do it, they came back and said, well, you know, was that the right number? And so we went through, did an analysis with them, and they actually came back and said, you know, we really want a /20. And so we went through this entire process with Aaron, which Aaron is great at helping you understand the process and what you have to do. And sometimes it was challenging for us to get all the information we needed from a VA perspective. But then again, the rules changed in the middle of our process. So that actually extended the entire piece by a number of months. So it actually took a while for VA to go back in, make the request that Aaron would accept, and come back, and it was agreed upon that a /24 would be allocated. So I think VA is probably one of the only federal agencies outside the DoD that's gone back and got a larger address space. And so this is one of the largest address spaces actually allocated, I think, out of Aaron. But there's a lot of challenges even within VA on addressing. As Ron said, the addressing plan for IPv6, I mean, you've got to get something in place and you've got to move forward. And I can't tell you how long VA had a paralysis that they didn't want to implement an addressing plan. And this is primarily from their operations team. They didn't want to implement an addressing plan unless they thought it was the final plan. And you have to keep coming back and telling them, no, you're going to readdress. You're going to have to readdress because you're not going to get it right the first time, the second time, third, fourth. You're going to do it, but you need to start making progress. And so that was a problem for a while that we finally overcame, is that they didn't want to allocate a number of the addresses out to the sites to move forward because they were afraid that in 2 more months they'd have to readdress again. And we finally got past that. But this idea of you've got this IPv4 thinking in there that says, we've got to conserve this address space as much as possible. And the idea of giving a /64 to a subnet, some people just don't want to look at that. Or a /48 to a site, they just don't want to look at that. Well, you've got to help educate them and help move them forward. And then major issues today, there's a number of them that the VA has come up with. The carrier services were a big one initially, and they continue to be to some point, but the carriers are catching up. They've actually realized, yes, the agencies are serious, and they're starting to provide that. The V6 spam filtering, that was a big issue for a little while for VA because there was not the reputation services out there that they were used to utilizing. And we had to go through and identify another process and methodology that they would agree to. USGv6 certified products. Well, the process is out there, it could be done, just the wealth of products is not necessarily there now. There's a number of vendors that have been pushing them through, but there's a lot of others that don't even understand what the certified product process is. And then internal issues, like I said, IPv4 thinking I think is one of the biggest ones. People think IP is IP, and to a certain extent it is, but we've grown accustomed to certain limitations in IPv4 and just made certain assumptions. And as we've grown in the field from an IT perspective, I think we brought a lot of people in, a lot of bright people, and you've trained them to do very specific jobs and not necessarily think of your network from a holistic viewpoint. They know how to do very specific things, and they've been trained with some of these mentalities, these limitations built in, and it's very difficult for them to take a step back and look at the big picture. Silo mentality, I think that happens in a lot of organizations where you've got different groups, they want to control different things. That's been a challenge. Some of the organizational processes. So, I mean, there's a number of challenges that VA faced and has overcome and still face for some of the other work that they want to do that is relevant to a number of different organizations. So that's a presentation for now. I think I'll turn it over to John Lee.
Thank you, Dale. Thank you. What I'm going to be talking about now is some of the infrastructure, some of the items. I'm going to briefly go over some of the comments that have been made already, but a slightly different perspective. But one of the major issues is in terms of the major V6 implementation with a least cost funding. Because when you're the federal government, when you have the largest set of V4 networks in the world, when you have literally billions of dollars in your networks, it's not something you do lightly. Just to make sure we have the rules of engagement, these are my accusations and don't represent anybody else's. In terms of the strategy, there were several strategies. One was that it needed to work with a number of other federal initiatives. Digital government from this administration, when the incoming president of the United States uses digital devices, and the first thing he's told by his national security group is that they're not secure enough for him to use and he can't use them anymore, then that's an issue. So there was an entire reassessment of the government's position in terms of the social media, the digital government initiative, something called DNSSEC, which is the securing the DNS environment, the trusted internet connection. And there was a requirement, because of the number of years, we'll be talking about that in a second, that you go ahead and you fund this as an initiative that goes through several capital budget cycles. So you don't look at using the other dollars. You have in the government what's called sustainment and technology refresh dollars. So you already budgeted to buy your routers. You already budgeted to buy your servers. What they were going to do is they were going to do some conformance testing. They were also going to put in requirements for that. So in terms of our timeline, one of the reasons that it was really important and critical that the government do this, and for those of you that aren't familiar with it, IP in DARPA was developed under federal funding, is you're talking about an initiative here of over 20 years. So this is not something that the commercial environment could really take into account. Several of the items were the FAR regulations, that was critical to a lot of this in terms of December 2009, when your actual FAR regulations went into effect, requiring that you have V6 support in products being purchased by the federal government. Am I doing that? So what we have here is we have the task force, and Mr. Van Rokel is the CIO of the United States, and he is took a personal interest in the V6 activities. Carol Bales, Pete Saronis, and Jane Coffin were the three that have been really pushing this. They also received their Internet Pioneer Awards for really moving the federal government in an expeditious manner from the federal government's perspective to V6. I am the deputy from ACT-IACT. ACT-IACT is a combination. ACT is the government side of it. IACT is Industry Advisory Council. And it's a number of organizations that do work with the federal government. You can talk to me about becoming a member of IACT. And we work in terms of traditionally a technology neutral as well as a vendor neutral situation with the government. Of course, by working with V6, we're not technology neutral for the V6 project itself. It's very important to understand the implications of the federal government and FAR regulations in terms of acquisition. The government spends $1 trillion, a little over $1 trillion every year, no matter what happens. So what's occurring there is a number of vendors take into account the federal acquisition regulations, take into account the requirements of the government as being potentially a significant part of their revenue stream. So when the government decided, unlike previous technology refresh cycles, to go ahead and say, we're going to go in, we're going to make modifications to the FAR. It occurred in 2006. It passed in 2009. Currently, all devices either are required to be V6 compliant or to get their CIO to sign off on a waiver. So and this is for all of the organizations that are supporting the federal government. This is for organizations selling services to the federal government. And shortly, it will probably be, again, in my opinion, if you are regulated by the federal government, if you're financial institutions, if you work with FCC, if you work with any of the federal agencies, they're going to be looking at your V6 plans, because if you do not have V6 plans, there are going to be questions about network security, network reliability, and really the viability of your networks in the future. In terms of federal CIO initiatives, there is what has already been discussed, HSPD 12, which is your standard ID. There's federal data center consolidation and cloud initiatives. All of these really leverage your V6 protocols. We, as the co-editor of the 2012 planning guide, what you have as an enterprise is you have the 2009 planning guide, which is really what is IPv6? What is this protocol? Go take a look at it. 2012, we totally rewrote the planning guide to be, you're implementing it, here are some best practices to implement, here are plans, here are stages. So it's really an entire template for your organization to take a look at. We've spent a lot of time with that. We've hit a number of activities. One, a couple of them that are on the screen here, a central addressing authority, because in IPv4 you had little islands of addressing so that you could have somebody distributed and taking a look at supporting that. From a V6 perspective, you have to take a look at the entire organization, items like that. In terms of multi-vendor services, so that you could make sure you have the reliability. Again, to address what everybody's talked about, here's one of Ron's favorite comments. You know, this is not your father's V4 network. As a network engineer, IPv6 is probably the 6th or 7th network protocol I've actually worked with. You have to look at the engineering aspects of IPv4, of IPv6, and as a dual stack network. So it's not that you bring one to the other, you have to attack them with the appropriate tools for the particular protocols you're interested in. In terms of network reliability categories, this is one that I've put together, and it's a reasonably standard set of categories. Traditionally, a number of organizations within the government have been what we call enterprise quality. That's because they've had small elements that they have been supporting and working with. It has been one of my objectives in working with the roadmap to move government networks to more of a service provider quality. Now, I'm not talking about the FAA, I'm not talking about National Command Authority, which have the entire set of other items. So in terms of a service provider network, you have to have something that's better designed, better engineered. You have to have integrated, automated systems, and you have 2 vendor policies. In terms of putting together operating support systems, network management, and cybersecurity, we're talking about better managing your addressing capabilities and have that in an automated fashion. Consensus audit guidelines for security, you can go through these in detail in the presentations themselves. These are things that need to be taken into account as part of securing your network. There are a number of them: malware defenses, continuous vulnerability assessments, when Joe talks about his security. So there's a cybersecurity ecosystem that ties all of this together. Again, one of the areas and strategies we've been putting together for the government. In terms of USG stats, these are some of the ones that you've already heard about. The USGv6 program for conformance and interoperability testing, or conformance testing, excuse me, is something that your organizations can take advantage of. Additional resources, the roadmap is, as I said, a very good document. There's digital government initiatives. There's a lot of online resources, including various gogoNET presentations from previous. There's a number of industry contributors in the room here. We have Dale. In the back, we have Joe Klein, we have Yuri Rich, and Chris Smith and other folks. Okay, that's our presentations. How much time did we have left for panel questions, or do we need to take them offline? 2 minutes. 2 minutes? Okay. Does anybody have any questions of the panel?
Check the roadmap. There's some discussion in there and some examples. In a number of briefings that you can find publicly out there, there's a lot of good examples, or I think even Owen's giving a talk here as well. He has some good talks on that. If you follow those guidelines, it's a good way to do an addressing schema. There's also a good RIPE document that talks about addressing that is online at RIPE. So there's a lot of resources there. But the main thing is throw away all your IPv4 thinking. Don't be conservative. It's a whole new paradigm, and you got to get your head around that, and then start doing your addressing plan based on some of those other talks that people have given, or those the addressing plan at RIPE.
We also have an address appendix in that we may be releasing for the roadmap document, either as an appendix to the document or separately. Contact me after the panel and we can talk in more detail, because I have a lot of information on that. It is a cost, but a lot of that is already taken into account. So what you're talking about is another 2 or 3, 4, 5% of activity that you're setting up your ACLs. Well, instead of setting up just your V4 ACLs, you're going to have to set up V4 and V6 ACLs. So yes, there is an incremental cost, but I would say that's a marginal incremental cost.
Well, in some cases, it may be marginal. So, we've done actually a lot of cost analysis and benefit analysis studies from a VA perspective. And, we have a back end now, so we're not completely within a technology refreshment cycle. So VA's been buying equipment, but if there's equipment deployed today and you're looking at a date of like 2015, well, you may be outside of the technology refreshment window. So you may have to pull some of that cost in. But like you said, if you have a carrier today that's not providing V6 service and you have them turn up V6 on a port, well, you may actually go deploy an engineer to go through and do some testing to make sure that's there, and you've got to build those cost factors in. In some cases, agencies or organizations may say, you know what, I've got X number of resources, I'm just going to prioritize, and so it's not going to actually incrementally cost me anymore. I just may push around what I'm doing. But in other cases, you may deploy a team of contractors, you may do something else, and it will be a real cost. So there are costs that are going to have to be built in. You're going to have other things like training. You're going to have other pieces, particularly like if you're doing applications and you want to do testing around that. So I wouldn't call the cost negligible, but it's something you really need to take a look at. Absolutely. That was one of the biggest cost items that we found from a VA perspective is, we've got thousands of in-house developed applications, and we've got to go through and we've got to take a look at every single one of those. And then there's going to be some assumption that there's going to be certain things that need to change. And so we built some algorithms to go through and do kind of a high-level estimate about how long it'll take for each one, how much it'll cost to go through each program, roughly how many lines of code may have to change, how much it's going to cost per line of code. I mean, none of those are going to be 100% accurate, but at least it starts giving you a good gauge. And then you've got to do that on a number of different areas.
The other item to take a look at is not just there's cost avoidance, but there's also the business opportunity. The federal government's really motivation was the fact that there are going to be citizens out there getting mobile devices that basically have V6 addresses. So the government's issue is they need to provide citizen services to all segments of the population using as efficient methods as they can. And when you begin to look at adoption of social media, when you begin to look at the capabilities of V6 to do more targeted marketing or more targeted supports of segments, of the citizenry, that's what the federal government's taking a look at. When you as an enterprise are looking to your customers, how can your customers get to you? It used to be you had a very nice building, you had a very nice physical location, because that was the first time the customer would see you. Now it's getting to your website. How clean is your website? How efficient? How responsive is it? And if somebody's website uses V6 and is more responsive than your website, then that's now going to that competitor. So it's really taking a look at both the business opportunity aspects as well as the cost. Are we pretty much finished, or can I take another question or two? Okay. You.
Looking at the NIST statistics, I was impressed by the degree of uptake of DNSSEC all the time. Now, there is a correlation between IPv6 and DNSSEC, because in the enterprise, DNSSEC is but below where VC is. So what would be your advice for that?
One of you guys want to?
I think I can address why that happened. It was because there was a push a number of years ago for .gov and .org to do DNSSEC, whereas the IPv6 mandate came later. So that NIST tracking site was actually doing DNSSEC monitoring long before it was doing the IPv6 monitoring. So it's just that this started earlier. That's why DNSSEC is way ahead.
And because of the quote-unquote Kaminsky refinding out the 2002, hijacking, DNS hijacking bug, that was a big political thing, and there was there was the traditional how you move things in Washington for DNSSEC. I believe we did, yes. But it was also a little more targeted, less servers. When you take a look at your DNS infrastructure, you're talking about 2 or 3 orders of magnitude less devices than you're talking about everything that attaches to your internet. Any other questions? We can do nothing about your taxes. No. Okay. Thank you very much.